Alright, what time is it? It's simplifying radical time. You know it. I got it. Let's do it. Who's pumped? Who's got two thumbs? This guy. Alright, let's get after this. Let's take a look at number one, the square root of 50. Well, not a perfect square. Let's break it down into something that can be a perfect square using factors. So that would be 2 times 25. Well, we know 25 is a perfect square, so it gets to escape. What's the square root of 25? Well, that is 5. The 2 has to stay inside the square root. So there is your final answer. Not too shabby. Take a look at number 2, square root of 90. Here we go. Break that down. Well, I'm going to break that down into 9 times 10 because I know 9 is a perfect square, so it gets to escape. The square root of 9 is 3. And 10 cannot be broken down into perfect squares, so it's just going to stay there, trapped inside the radical sign. Done with number 2, moving on to number 3. Square root of 98. Let's see here. What are two numbers I can break that down into? How about the square root of 2 times 49? Boy, I got that pretty quick. Could it be that I have the key? I don't know. But the 49 is a perfect square, so it gets to escape. When it escapes, it becomes a 7. The 2 is stuck inside the perfect square, or inside the square root or the radical symbol. So there's your final answer there. Square root of 24. Again, 24 can be broken down into 2 and 12, 8 and 3, 6 and 4, a bunch of different things, but I'm going to find something that is a perfect square, and that is 4 times 6. 4 is the perfect square. It gets to escape. That becomes 2 times the square root of 6. 6 cannot be broken down into perfect squares. And finally, the last one, 72. Well, 72, I can break that down quickly into 2 times 36. I just love my factors. So which one of those is a perfect square? Obviously 36 is. Square root of 36 is 6. That is 6 times the square root of 2. So that takes care of the first column where we don't involve variables. Now let's get crazy and start talking about some variables. Here we go. And as you can remember from last week's lessons, when we're dealing with variables in the square root symbol, we like when there is an even exponent. If there's an even exponent, it gets to escape. Just divide by 2. Take the exponent, divide by 2. So x to the 4th does get to escape. It just becomes x squared because I divided 4 by 2. Take a look at number 7. Again, we like the even exponent. It gets to escape. It escapes by dividing the exponent by 2. So 10 divided by 2 is 5. Y to the 5th. That one is done. Oh dear, look out. We've got two variables. No big deal. They both have even exponents. So they both get to escape. So x to the 6th, the square root of that becomes x to the 3rd. Y to the 8th, the square root of that becomes y to the 4th. Bingo, bongo, bango. That one is done. Now, here we have a coefficient in front of the variable. No big deal. The good news is that the coefficient is a perfect square, so he gets to escape no matter what. Y to the 8th is even. It also gets to escape. Everybody's happy. Here we go. The square root of 16 is 4. Y to the 8th gets to escape by dividing the exponent by 2. Well, 8 divided by 2 is in fact 4, so that becomes y to the 4th. So 4 times y to the 4th is your final answer there. And the last one on this page, here we've got 36, a to the 6th, b to the 2nd. Well, 36 we like is a perfect square. A to the 6th, even exponent. B to the 2nd, even exponent. All is good. They all get to escape. So the square root of 36 is 6. Divide your even exponents by 2. So a to the 6th becomes a to the 3rd. And b to the 2nd becomes b. There's your final answer there. Okay, so that takes care of the first page. Let's go and move on to page number 2. Here's where they get a little bit more difficult because we've got numbers outside the radical symbol and we've got non-perfect squares and we'll have some odd exponents as well. But again, last week we went over this stuff, so if you're still having problems, try to pay a little bit, pay some attention, I guess I should say. So let's take a look at number 11. So I got a lot of writing to do here. So the 3 is going to stay outside. It's going to multiply anything that escapes. Well, 50 can break down into 2 times 25. X to the 8th is good news, even exponent. So what can escape? The 25 and the even exponent. So the 25 escapes. What's the square root of 25? Well, that's 5. We'll multiply it by the 3 out front. So 3 times 5 is 15. The x gets to escape. So you divide that exponent by 2. 8 divided by 2 is 4. So the x's are gone. And unfortunately, the only thing that's left on the inside is, in fact, that 2. Okay, take a look at number 12. Something very similar. Again, it's kind of good news in this one. We got a perfect square and an even exponent. So the good news is they both get to escape. So this 4 outside is going to be multiplied by whatever the square root of 9 is. Well, the square root of 9 we already know is 3, so that's going to be 4 times 3, which is 12. X to the 14, divide that by 2. That becomes x to the 7th. There is your final answer there. Okay, take a look at number 13. Now here's where we have an odd exponent. We learned last week, well, if you have an odd exponent, just break it down into something that has an even exponent. And we said, okay, let's do that as y to the 1st times y to the 8th. Because we know 1 plus 8 is 9. This is multiplication. You add your exponents, this does work out. So now, unfortunately, though, when you do that, only one of the guys gets to escape, and that's the one with the even exponent, and it divides by 2. So this one becomes y to the 4th. And unfortunately, the y to the 1st stays inside the radical symbol because it cannot escape with an odd exponent. Okay, take a look at number 14. This one's got a lot of work involved. So again, break down to 54. So I'm going to write 2. 54 can be broken down into 9 times 6. X to the 8th is cool. It's got an even exponent. Y to the 11th, odd exponent. We don't like that. So we're going to do y to the 1st times y to the 10th. So I'm going to underline everything that can escape. 9, the even exponents get to escape. And the y with the even exponent gets to escape. So the 2 is going to multiply by the square root of 9, which is 3, so that's 6. Here, x to the 8th, well, divide that by 2, so that becomes x to the 4th. Here, y to the 10th, so that escapes by dividing by 2, so that becomes y to the 5th. Now, whatever's remaining on the inside, whatever didn't get to escape, so this 6 and this y didn't get to escape, so 6y. So there's your final answer. Okay, bottom one, number 15. So that's 7 hundredths a perfect square. I'm not going to touch that one. 8 to the 9th, well, again, that's odd, so that's going to be 8 to the 8th times 8 to the 1st. B can't do anything with. C to the 14th times C to the 1st. Extend that. So now let's underline everything that can escape. 100 gets to escape. A to the 8th gets to escape. And C to the 14th gets to escape. So those 3 guys are going to escape. So let's do the square root of 100 is 10. So 7 times 10 is 70. A to the 8th, divide that by 2, becomes, becomes A to the 4th. C to the 14th becomes C to the 7th. Now the only thing that remains on the inside are items that could not escape, like the A, the B, and the C. So A, B, and C. Okay, almost done. We've almost made it. Got 5 more problems to do. I think we can do it. Let's take a look at 16. So again, I got a top number that's a perfect square and a bottom number that's a perfect square, so just get them out. Get them out of there. Escape them. So x to the 4th, divide that by 2. That becomes x squared. Square root of 16, I know, is 4. That is your final answer. Okay, 17, I'm going to clean up a little bit on the inside. I know 8 divided by 2 is 4. And remember way back when, x to the 5th divided by x, well, you subtract your exponents, so that's going to be x to the 4th. So now they're both perfect squares, you can escape. Square root of 4 is 2. Divide by 2. So that becomes x squared. Take a look at 18. So let's take a look here. Everything is, we got a perfect square on top, perfect square on the bottom. They get to escape. Even and even, they both get to escape. So let's go ahead and do that. So square root of 36 is 6. Square root of 25 is 5. The square root of x to the 6 divided by 2 is x to the third. The square root of x squared is x. And the last thing you do is simplify your x to the third over x to the 1. So you subtract your exponents. So the final answer there would be 6 over 5 x squared. Okay? And then finally, combining like terms. This was the last section in this unit. We talked about how you can only add or subtract things that have the same caboose. Well, the good news is they both have the same caboose of the square root of 6x. So then just go ahead and add the big numbers up front. So 3 plus 4 is 7. Keep the caboose the same. And there is your final answer. Not too shabby. And finally, the last one. Can't believe we made it. I'm going to underline everything that has the same caboose. So square root of 3xy, square root of 3xy. And then double underline the other two guys. So square root of 2y, square root of 2y. So you can only combine items with the same caboose. So I'm going to focus on the red. I've got 2 minus 8. So 2 minus 8 is actually a negative 6 times the square root of 3xy. Now take a look at the green guys. The green guys, I've got 5 plus 8. That is 13. That's plus 13 times the square root of 2y. Okay, and that's as far as I can take it. All right, so again, this was a little bit of review for your quiz that's coming up on Monday. Again, as always, if you have any questions, please check us out during office hours. Feel free to go back and review any of the material that we've talked about, any of the videos that we've done. Also, feel free to take screenshots for any of your book creator pages. You could use any of these from this review sheet or the previous units or previous lessons. And again, if you have any questions, please contact us. Good luck.